Hello and good evening, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to the Conqueror channel. And I welcome you all to my session of Antennas MCQ series. This is going to be a very important series, dear, because we are going to cover comprehensively all the MCQs related to antennas at a given place in a given series. That's the reason this particular series on MCQs is going to be very important here. So those who are new to the channel, subscribe to the channel very soon and also share this particular class among the maximum people. Before we start the class, let me introduce myself. I'm Chaitanya Reddy. Having overall experience of 15 years in teaching, guiding and mentoring 8 and DSC aspirants. I work as motivational speaker, pan-India from the past 12 years, an expert in field theory and communications. And on this channel, you have some exclusive content related to field theory. Just confirm the video and audio once, dear. Just confirm the video and audio once. Yeah. And this is official link for the Telegram channel of the Gate Conqueror channel. This is an official Telegram link. And this is a link where you can join us on Telegram. This is official Telegram for the Gate Conqueror channel, where you can access all the faculties of the Gate Conqueror channel, including the legendary K.M. Rao sir. So for a personal level assistance from all the faculties of the Gate Conqueror channel, you can just click on this particular link, or you can take a screenshot for the same and use this link to join us on Telegram. So we are into the Antennas MCQ series, part of EMFT, and as you know, we had comprehensively covered the concepts of EMFT. We had comprehensively covered the concepts of EMFT in this particular series. Just a second here. 1 second. Just give me one moment, okay? One moment. Okay. Fine. So what we had covered over here in this EMFT, let me explain for a few minutes. All those who have joined new to this particular channel, I can say you that in Gate Conqueror channel, we have some exclusive content for EMFT, and the good news for all the Gate Conqueror followers is that we are now increased in number. More new, energetic and talented educators with lots of experience are going to join us within few days. Within few days already joined, but they will come live onto this platform within a couple of days. So all these people are going to come live on the YouTube platform in our channel, and we are planning as a team. We are planning to cover comprehensively all the subjects of ECE and electrical, targeting GATE 2023 and ESC 2023. So that's the target here. Now we have enough number of faculties with us to comprehensively cover the syllabus and target GATE 2023 and Engineering Services 2023. As part of that, let me explain how far one of the important subject for both EC and electrical. EMFT has been covered in this particular channel. In EMFT, we have total of 5 modules, in which module 1 is elements of EMF theory. This is common for ECE and electrical. For ECE it is complete syllabus. For electrical it is complete syllabus, and for ECE it is module 1. Remember, for electrical this is complete syllabus. Module 2. EM wave propagation, and the rest of the modules are only for ECE. Module 3, transmission lines. Module 4, wave guides. Module 5, antennas and optical fiber communication. In this, good morning Prakash. In this 5 modules, I like to explain how many modules are already explained in detail on our channel, and what parts of this are left out, I'll explain in detail. Let me start with module 1. Module 1 is elements of EMF theory. Told you common for EC and electrical. On our Gate Conqueror channel, we've already created a playlist on this. Which contains "40 videos and 50 hours of lecture, which covers complete theory, all derivations of this particular module, all previous year questions, and many practice questions, which covers both EC and electrical. For Gate and engineering services, both. See dear, Baumik, good morning. Chakravarti, good morning. If you go for any of the playlists on YouTube, maximum what you find is 8 to 10 hours of maximum, I'm saying maximum 8 to 10 hours of theory you can find for module 1. Whereas we had covered 50 hours, or we had delivered 50 hours of content only for module 1, that is elements of EMF theory. Just you can imagine, using this content very easily, you can go through GATE and ESC for 2023, fully comprehensive course for module 1. What we had covered in this module 1 is we divided this into 2 parts. And static field theory, first part is static field theory. The second part is time varying field theory. In static field theory, we covered electrostatics, and magnetostatics. And the electrostatics and magnetostatics put together, we covered Maxwell equations, for static fields. Under Maxwell equations for static fields, first equation we had covered is on Gauss law. Integral form, closed surface integral of d dot ds is equal to volume integral of rho v dv. Good morning, Rohit. And differential form, del dot d is equal to rho v. And this Sunday, 6 a.m. Remember, dear, there is a small residual part that is left out in module 2. I'll take a marathon and complete that, okay? Sunday, 6 a.m., remember. March 6th. So, del dot d is equal to rho v. Source Gauss law for electric fields. Second equation, closed loop integral of E dot dl is 0. Del cross E is equal to 0. which is from conservative property of electric field. Bhaumik, Rohit, how are you? Third equation, so Ampere's law. Closed integral of h dot dl is equal to surface integral of j dot ds. Differential form del cross h is equal to j. Source Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Differential form del dot B is equal to 0. Source, non-existence of magnetic monopole. Gauss law for magnetic fields. These two are from electrostatics. The later two are from magnetostatics. So we are derived. We have done previous year questions on this. We have done the derivation. We have seen the applications. We have done practice questions completely. We have completely comprehensively solved these Maxwell equations. Of course, there are so many topics we have covered. These are the main topics that we have covered in this particular playlist of 50 hours and 40 videos. Other than electrostatic and magnetostatic main concepts of Maxwell equations, we had also covered Poisson's and Laplace equations, boundary conditions. These are the most important topics. Capacitors and inductors. And in the second part, in the second section, we had covered time varying field theory. In time varying field theory, again we have derived Maxwell equations for time varying fields. And in that, Maxwell equations for time varying fields, equation 1 and equation 4 are same. Only 2 and 3 will vary. 2 we are varied using Faraday's law. And 3 we are varied by Maxwell contribution. So, under time varying field theory, mainly we have discussed about Faraday's law and varied equation number 2 for time varying fields. Closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. Integral form, differential form. Del cross E is equal to minus dou b by dou t. Next. We had modified equation number 3. Concept of Maxwell contribution. What does closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds. J is conduction current density given by sigma E, depends on conductivity of the material. jd is displacement current density given by dou d by dou t, depends on time varying electric field. Differential form del cross h is equal to j plus jd. This was from Maxwell contribution. So thereby we got Maxwell equations for time varying fields. So this is the main concept, and besides that we had covered all the topics. The extra topics that appear in engineering services, their derivations, their applications, previous year questions of GATE and engineering services, completely we had solved in module 1. So definitely this will be helpful for both GATE and ESC preparation for EC and electrical people. 40 videos are already been recorded with 50 hours of content. Almost 5-fold more than what is available on any YouTube channel. This we had covered in module 1. And not only that, the highlight for this module is that we had covered basics like never before. 14 hours, only basics were discussed. In basics we had discussed elements of vector calculus, where we have discussed under elements of vector calculus, we have discussed addition of vectors, subtraction of vectors, multiplication of vectors, and properties of vectors. This we have discussed under elements of vector calculus. Good morning, Surendra. And second half we have discussed about coordinate system, types of coordinate systems. We have discussed about Cartesian, cylindrical, spherical coordinate system, the coordinates, limits, point transformation, how to transform a point from one coordinate system to another coordinate system. Discussed main concepts like divergence, curl, gradient, and Laplacian in all the different coordinate systems, and also some wonderful shortcuts and previous year questions, practice questions from these basics have been exclusively covered. And also exclusively we have covered unit vector relations, which is rarely covered by anyone. So these are the highlights of module 1, dear. Just go through module 1. This must be useful for your GATE and ESC. You have some exclusive content, 4-fold or 5-fold more than what other channels will offer. So let us all target GATE 2023 and ESC 2023. We are here to help you as a team. Next is module 2. Module 2 is EM wave propagation. Under EM wave propagation, we discussed on EM wave propagation in free space. Free space is a case where conductivity is sigma 0, epsilon r is equal to 1, and mu r is equal to 1. And we had seen EM wave propagation in materials with finite conductivity or sigma not equal to 0, epsilon are greater than 1 and mu are greater than 1. Under EM wave propagation in free space, we have derived the value of alpha, beta, velocity and eta. Under EM wave propagation materials, we have derived alpha, beta. These are generalized expressions we have derived. Velocity, eta. These are generalized expressions for alpha and beta we have derived. Loss tangent, a dissipation factor, sigma by omega epsilon. Then we discussed on EM wave propagation. In good conductors, sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon is greater than 100. This is what we have discussed in EM wave propagation in good conductors. Then we discussed on EM wave propagation good dielectrics. Sigma far less than omega epsilon. Sigma by omega epsilon far less than 1. sigma by omega epsilon less than 1 by 100, 0.01. Under this, for good conductors, we derived value of alpha, beta, velocity, and also we discussed on penetration depth or skin depth. Surface resistance and intrinsic impedance. Here, loss tangent or dissipation factor is given by tan of phi, where phi is 2 times of theta n, and theta n is the angle of intrinsic impedance. EM wave propagation in good dielectrics. Derived alpha, beta, velocity, and eta. And also we had completed EM wave propagation in perfect dielectrics. Sigma 0 epsilon are greater than 1 and mu are greater than 1. Here also we derived expressions for alpha, beta, velocity and eta. Complete theory. All derivations. All previous year questions. So many practice questions we had covered here. In these 5 topics, and detailed analysis of this EM wave propagation was also done with a comparison table also. Please go through the EM wave propagation series for detailed explanation about these concepts. Clear? And also we had covered pointing theorem. Theory and derivation of pointing theorem is done. The most important pointing theorem which explains about the power associated with the given EM wave. The derivation for the same expression for instantaneous, complex, average, real and imaginary pointing vectors is been derived. Theory part is completed. What is to be completed is we need to solve previous year questions plus practice questions which are pending. We took here in this playlist EM wave propagation, completed 8 videos, 18 hours of recording. Again, max to max here. You'll have 7 or 8 hours of content for EM wave propagation, but where we have recorded already 18 hours of content. And this topic is left out. Previous year questions and practice questions we need to solve, which I'll discuss in part 9, the 9th video. Along with that, 2 more topics are left out. Just wave polarization, reflection and refraction of plane waves. These topics are left out. This also we'll discuss in detail. So I'm planning for this on this Sunday, 6 a.m. session. There will be a marathon session where we'll complete this and complete this module. So many students are asking to complete the module. So we will do that. We'll do that mostly by taking one session. If not, one more session. So max 10 videos and 25 hours. We must complete this. Mostly by this Sunday I'll complete this. 6th of March. Okay. Fully updated module you'll get on module 2. Module 3 we are not done. Remember, this Sunday we'll complete module 2. Okay. Module 3 transmission lines not started. Module 4 waveguides not started. Both this will start parallelly. Both those will start parallelly here. Okay. So these both modules we are going to start parallelly. Don't worry about this. In module 5, antennas and optical fiber communication. Optical fiber communication I'll deal separate series. I'll take a separate series. On optical fiber communication. But on antennas already we had started a series with the name Antennas Maha Marathon series. Where we have created a playlist. (18 videos and 38 hours of content is already done. Is that clear? In this Antennas Maha Marathon series, We started with basic terminology. Of antennas. Current distribution in antennas. Radiation mechanism of antenna. In which we had covered single wire radiation, two wire radiation, radiation by a dipole. And the formula for the antenna to radiate is L into di by dt is equal to Q into acceleration. When this equation is satisfied, the antenna will radiate. Then we are seeing the radiation pattern of antenna. Under radiation pattern of antenna, we have seen main lobe, side lobes, nulls, first nulls, back lobe, side lobe lever or side lobe ratio, beam widths. We will cover beam width between first null and half power beam widths. All this we are covered in radiation pattern of antenna. Then we are covered radiation parameters of antenna, in which we have covered simple gain, directive gain where losses are not considered, power gain where losses are considered, directivity, efficiency, radiation intensity, radiation resistance of different types of antennas, apertures of antennas and their types, expressions for alpha, beta, gamma, effectiveness ratio, scattering ratio and absorption ratio, and beam area. Many other concepts were discussed under radiation parameters of antenna. This we discussed under radiation parameters of antenna, and also we discussed about basic antennas like monopole antenna, dipole antenna, its radiation pattern, and loop antennas. This we have discussed exclusively monopole, dipole and loop antennas. And besides which, exclusively we discussed about antenna arrays. In antenna arrays we discussed on two element array. In detail analysis of the 5 cases of two element arrays were discussed in detail. Along with that, we have discussed n element array. Mainly, we are focused on the concept of broadside array with n element and endified array with n element. And of course, under antenna arrays, we had also discussed types of arrays, which are broadside array, endified array, collinear array, and parasitic arrays. And also we have discussed some special arrays. Hansen and Woodyard array, which is also called as endified array, with increased directivity. Using this procedure, directivity is increased by 78.9%. And the technique here is, instead of using alpha is equal to minus beta d, we maintain alpha is minus beta d minus pi by n, where n is number of elements. By doing this, the directivity will be increased by 78.9% of that of the general endified array. And also we discussed on a special array named binomial array. Binomial array is a special case of broadside array with non-uniform amplitude distribution. With non-uniform amplitude distribution. These were the concepts that we had discussed in antenna arrays. And also we discussed about the 7 sisters. Seven sisters, I mean to say, just like 7 sisters said, these are 7 important antennas. In which we have discussed about folded dipole antenna, one second. One second. Fine, thank you. Under 7 sisters, we have discussed about folded dipole antenna, which exhibits very high input impedance, useful for matching purpose. Or whenever the antenna gets loaded, it will be used for matching the feeder. Then we are using an Yagi-Uda antenna. We discussed about Yagi-Uda antenna. It's a parasitic antenna, example of a parasitic antenna. Mostly with a folded dipole as its driven element. And this parasitic array antenna contains three main elements, which is driven element where the power is fed or taken from it, and a set of directors and a reflector. Let's see about helical antenna, the most popular antenna for circular polarization used in space propagation. We discussed about the helical antenna and the modes of propagation, mainly normal mode and axial mode. Normal mode and axial mode. The normal mode is length is very small. Total length n into L is far less than lambda. In axial mode diameter, which is pi d. In axial mode, the circumference, which is pi d, approximately equal to lambda, implying the diameter is approximately equal to lambda by 3. These are used in applications like Wi-Fi router. These are used in applications like space wave communication and satellite communication. And also we discussed some very important points like pitch angle, design factors which are responsible for generation of circular polarization. For in detailed discussion, please go through Antennas Mahamarathon series. Then we discussed on microstrip array antenna, horn antenna, which is standard antenna at high frequency, parabolic reflector antenna, and lens antenna. We discussed on the 7 sisters. And also a special discussion on resonant and non-resonant antennas was made. Under resonant, we have discussed about monopole and dipole antennas. The non-resonant antennas, discussed on V antenna, inverted V antenna, and rhombic antennas exclusively. This is also exclusive content. And most probably you will never get this 7 sisters content anywhere. In detailed explanation of all these 7 sisters, you will never get in any playlist on YouTube. And not only that, we discussed a very important antenna measurements also under this series. Under antenna measurements, it focused on radiation pattern measurement, we discussed basic setup required, radiation pattern measurement, Then we have discussed on high frequency method and low frequency method. High frequency measurement or measurement at high frequencies. Both primary and secondary antennas are kept stable, and secondary antenna is rotated on its own axis. The part of radiation pattern measurement technique. And at lower frequencies or at low frequencies, primary antenna is kept stable and secondary antenna is rotated at constant radius around primary antenna. This is for low frequency measurement concept. Under radiation pattern measurement, two important things, that is measurement of gain and measurement of directivity. Under measurement of gain, we have seen three antennas method. Also called as first method. And we have seen the second method, which is measurement of absolute gain. And under directivity measurement, because the directivity is 5 max by 5 AV, 5 max by 5 AV is WR by 4 pi. 4 pi times of 5 max by WR. 4 pi times 5 max by WR is double integral of phi of d omega. Where d omega is the elementary solid angle given by sin theta, d theta, d phi. So very clearly here there is a double integral with respect to theta and phi. As double integral is involved, general calculation is not possible. We go for graphical numerical methods. What are graphical numerical methods? Orange slice method. In graphical numerical methods, one of the parameter, either theta or phi, will be kept constant. So literally making it as a single integral concept. The two methods are orange slice method and conical cut method. Orange slice method and conical cut method. So this we discussed under antennas. Under wave propagation. Now this from wave propagation will be useful for engineering services. In wave propagation, we covered principal modes of propagation, which are ground wave propagation, frequencies up to 2 MHz are used here. skywave propagation, frequencies between 2 MHz and 30 MHz are used. So here in detailed explanation of all these modes of propagation I had explained in Antennas Mahamarathon. Please go through it. Space wave propagation, between 30 MHz to 300 MHz. Discussed on special modes of propagation. Under special modes of propagation, we have discussed on scatter propagation. Under scatter propagation, we had seen tropospheric scatter propagation, and ionospheric scatter propagation. One more special mode of propagation we had seen is duct propagation. All the derivations, previous year questions, everything is solved for this 5 modes of propagation, which are 3 principal modes of propagation and 2 special modes of propagation. Besides this, we have also seen structure of atmosphere, we covered structure of troposphere, and structure of ionosphere, and the structure of troposphere. Let's see how the wave propagates in troposphere, and structure of ionosphere. Exclusively all the layers, stratification process, everything we had covered in the Antennas Mahamarathon series, dear. Please go through the series for detailed explanation about the structure of ionosphere. Very important. Then we have done derivations which are useful for engineering services. We have done derivations for refractive index of ionosphere, mu or n, sin I by sin r, under root of 1 minus 81 n by f square. Let's see the mechanism. Of radio waves bending by ionosphere. We discussed on the concept of virtual height. H prime, we derived it as Ct by 2. Where T is a two-way time taken for a impulse signal vertically sent upward to reach there and come back to the earth surface. Seen expressions for critical frequency. Nine into under root nm. Fc measured in megahertz. And nm ionic density in per meter cube. Then we have seen maximum usable frequency. We have related maximum usable frequency to critical frequency. FMEF is equal to FC secant I. It's called as secant law. And also we had seen least usable frequency. skip distance, and optimum working frequency. This skip you got it as 2h into under root of FMUF by FC whole square minus 1. FMUF and FC are related by FMUF is equal to FC into under root of 1 plus D by 2h whole square. So we discussed on these topics. Along with that, we have discussed on ionospheric abnormalities. We discussed 10 different points in it. And we have discussed a derived range of space wave propagation. We have derived expression for received electric field strength in space wave propagation, which is ER is equal to 88 root P HD HR by lambda D square. And also we had a discussion on fading and path loss calculation. Total path loss given by 32.45 is 20 log frequency in megahertz, is 20 log distance in kilometer. So all this detailed explanation we have done in this detailed explanation under the concept of antennas. So go through antennas Mahamarathon series for the same, where there are 18 videos and 38 hours of recording is there, exclusively covering module 5. Exclusively covering module 5. So I can say here on Gate Conqueror channel, you can find exclusive content for comprehensive preparation of EMFT in the form of 3 playlists. In the first playlist, Elements of EMF Theory, we have 50 hours of recording. Second playlist, we have EM wave propagation, 18 hours of recording. Antennas, module 5, we have 38 hours of recording. Overall, we have 106 hours of recording already available for Gate 2023 EMFT. And I am planning 114 more hours. We'll make it 220 hours of recording for EMFT, covering all the modules. Clear? Now, tell me this answer here. Non-resonant antennas carry dash current waves. Non-resonant antennas carry dash current waves. Non-resonant antennas means antennas terminated in its load impedance. The wave is traveling, the current wave is traveling. Here it is terminated in its impedance. So there is no standing wave. The wave will not come back. Only one wave, one side wave will be there. Therefore this is called traveling wave. This antenna which is terminated in its load impedance RL is called a non-resonant antenna. Therefore a non-resonant antenna carry what? A non-resonant antenna carry traveling wave. Question number 1, option A is the answer. Non-resonant antennas. What kind of antennas? Non-resonant. All non-resonant antennas are wideband antennas which can be operated over wide band of frequencies. All resonant antennas are narrow band antennas. They are sensitive to frequency or sensitive to wavelength. They are narrow band antennas. Now what is given? Non-resonant antennas are dash antennas. Their by default broadband antennas can be operated over wide band of frequencies. Examples: V antennas, inverted V antennas, rhombic antennas, helical antennas, Yagi-Uda antennas. All these are broadband antennas which can be operated over wide band of frequencies. Therefore, question number 2, option B is the answer. Non-resonant antennas are, out of this, identify non-resonant antennas. Definitely V antenna is a non-resonant antenna. You can see the V antenna structure. This is the V antenna structure. Terminated in its impedance. Is also terminated in its impedance. This is beta inclination angle. This is the radiation pattern. It looks like this. This is a beta inclination angle, and this is gamma included angle. Basing on this gamma and beta, we'll have some interesting relation of how this antenna will be operating. That we'll discuss in the later questions. Okay. Now for now, non-resonant antennas are V antenna, non-resonant. Rhombic antenna is formed by V and V and inverted V, which is also called as a curtain antenna. Is also wideband antenna, and which is also non-resonant antenna. Helical antenna is also non-resonant antenna, but it is operated in axial mode by default. When it is not given, remember dear, if nothing is mentioned, by default helical antenna is in axial mode only. In axial mode it is a non-resonant antenna. In normal mode it is a resonant antenna. We'll have a discussion when I am discussing on helical antennas on this. Dipole antenna, definitely resonant antenna, narrow band antenna. So the non-resonant antennas are 1, 2 and 3. 1, 2 and 3. Remember dear, this is the ambiguity here. If nothing is mentioned, by default you must take it as axial mode. If it is normal mode, you will mention, and helical antenna in axial mode is non-resonant antenna. In normal mode it is resonant antenna. Please make a note of this dear. If nothing is mentioned about this, by default helical antenna that is given, you must take it in axial mode. Yagi-Uda antenna is a dash antenna. Yagi-Uda antenna is a special case of a non-resonant antenna. Remember, very important question. Yagi-Uda antenna is a special case of non-resonant antenna. Very important. And helical antenna, in axial mode it is non-resonant, and in normal mode it is resonant antenna. Very, very important. Please make a note. Everyone please make a note. Dipole antenna is, we all know dipole and monopole antennas are resonant antennas. There is no doubt, and they are sensitive to frequency, therefore they are narrowband antennas. They are narrowband and resonant. 1 and 3. Option B is the answer. Resonant antennas, that means which are not terminated, they carry dash current waves. Is the incident one. There is no termination, the wave will come back, forming standing waves. Forming standing waves. Forming standing waves. It forms standing waves. Therefore, resonant antennas carry dash current waves. Resonant antennas carry standing waves. Option B is the answer. Resonant antennas exhibit dash pattern. In resonant antenna, We have both forward wave and reverse wave forming standing waves. Forward wave will result in this V-shaped pattern. Reverse wave will result in one more V-shaped pattern forming a flower-shaped pattern or a bidirectional pattern. Because this two will result in this lobe and this two will result in this lobe. So it results in a bidirectional pattern. Resonant antennas exhibit dash pattern, bidirectional pattern. Non-resonant antennas exhibit dash pattern. If you take a non-resonant antenna, like a V antenna, then you have the pattern like this, and you have the pattern like this. These both will cancel out. These both will add up, forming a large unidirectional pattern. Non-resonant antenna exhibit dash pattern, unidirectional pattern. As length of the radiator increases, the angle between traveling wave radiator and direction of maximum radiation. See, for example, this is the length of the radiator. The angle between the traveling wave radiator, this and the direction of maximum radiation. What it is happening? If you increase the length now, this was the previous length. If you increase the length of the radiator, you will find the pattern like this, where the angle between the radiator and the maximum radiation, for example theta, is getting decreased here. If you still increase the length, still getting very close, theta still decreases. As the length increases, theta is getting decreased, or the main lobe is aligning more. The direction of maximum radiation is aligning more to the radiator. You can see the angle which is decreasing. So as the length of the radiator increases, the angle between maximum radiation and the direction of maximum radiation decreases. Now you may say, sir, it's a very good thing, then we'll take very long antennas. If you take very long antennas, the problem is, not one advantage is that this angle between the maximum radiation and the traveling wave radiator is decreasing, but number of side lobes will increase. For example, now you have two side lobes. If the length increases, alignment will increase, but side lobes will increase. You're having more side lobes, that's the problem. That's why you cannot take indefinite lengths. You must take a compromise between this alignment and side lobes. If side lobes are not required for you, try to limit the length. If you want more alignment, more unidirectional radiation pattern, side lobes will not matter for you, then increase the length. Increasing length also is one of the geometrical constraints you need to remember. Now you see, as the length of the radiator increases, the number of side lobes, as I told you, as the length, first time the length is this, the maximum radiation angle, and these are two side lobes. If the length increases to this is the length now, then alignment, direction of maximum radiation will come closer to the radiator, but the problem is number of side lobes will increase. If you still increase the length, you'll get more alignment. The problem is, you'll get more alignment, but the problem is you'll get more number of side lobes. Very, very important discussion here. As the length of radiator increases, the number of side lobes increases. So question number 10, option B is the answer. Very, very important here. Some more discussion on V antennas, inverted V antennas and rhombic antennas. We'll try to do it in the next session. Okay. Unacademy has two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank room batches and crash courses. In Iconic, we'll have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions and study planner. And if you're going for a Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI. The total cost will be divided by number of months without any extra charge, and you can use our team code KNR10. The speciality of the team code is you'll not only get 10% off, but you'll get all the team support. With the Iconic subscription, you'll get 1:1 live mentoring, which increases your chances of getting a top rank. And with every 1 year subscription, we are giving away 6 months extension for the same. So accelerate your preparation using our code KNR10, which gives you not only 10% off, but also complete team support. And if you are talented, I recommend you to go for a combat, which is live quiz competition. The next combat is on this Sunday, March 6th, 11 a.m. 20 questions will be asked, 60 minutes will be given, and a separate paper will be given for mechanical, civil, electrical, EC and CSID. Those who score rank 1 to 3 will give away 100% scholarship, 4 to 10 will give away 75%, 11 to 15 will give away 50%, 51 to 500 will give away 25% scholarship. And the good news is, we need not pay anything to write this combat. Enrollment is free. Just use our team code KNR10. And if you are having any doubt in your preparation journey, subscriptions and latest offers, you can contact our counselor. The number to contact our counselor is given here. Unacademy has introduced a feature called Ask a Doubt, through which you can ask unlimited number of doubts here. So we are here to clear all your doubts. You can ask 3 doubts at a time, and you can get the solution in your preferred language. It's very easy to ask your doubt also. Just click, crop and submit. The super combo offer going on. With every 2 year subscription, we are giving away 1 year subscription for campus placement and IT jobs. With every 1 year subscription, we are giving away 6 month subscription for campus placement and IT jobs. The rank predictor, which is on here, just easy, very easy to check your rank. If you are attempted GATE 2022, just log in, go to GATE landing page and click on the rank predictor banner, select your stream, select your session, paste the URL, your rank will be displayed. These are special class features here where you have interactive live classes for the learners, polls for the learners, raise the hand option. You never miss a class when the notification is on. After the class, immediately you can download the lecture notes and you can access anytime and anywhere. We are introducing community, through which you never miss any updates from your favorite educators. You can download notes and practice material, and you can also give the feedback directly to your educator via polls. These are the new batches here. Every week we'll start almost 7 to 8 new batches. These are the new batches started on March 2nd, which are Verb GATE 2024 for electrical explained in English, Ascent GATE 2024 for EC explained bilingual, Ascent GATE 2024 for electrical explained bilingual, Evolve GATE 2023 for electrical explained bilingual, Spark GATE 2023 for electrical explained in English, and Verb GATE 2024 for electrical explained in English. These are the new batches here. You can join any one of them. Each week we start 7 to 8 new batches. So nothing to worry. Thank you everyone for joining. Let us meet in the next session. Thank you all.